Hello, my dear students. In the previous video, we have discussed about the combination reaction. And in this video, we are going to discuss about the decomposition reaction in detail along with the activities. Yes, let's get started. First of all, let us understand the meaning of decomposition reaction. The reaction in which a single reactant will break down to form two or more simple products, then we call such reactions as decomposition reaction. The main thing which we have to observe here the single reactant will break down to form two or more simple products. The reactant will be only one, which will undergo decomposition to form two or more simple products. The decomposition reaction can be represented generally as, suppose this is a single reactant. It undergoes decomposition to form simple products. Two or more products may be formed here. This is the general representation of the decomposition reaction. Now we shall study the different examples for decomposition reaction by using activities. Studying the reaction along with the activity is very important because many a times in your exams, what they do is they ask the observations for different activities. So let us study the different reactions by using activities here. Let us start now. Activity 1. Take calcium carbonate or limestone in a test tube. We know that calcium carbonate has the chemical formula CaCO3. Place a delivery tube with a cork on the tube. Heat the tube using burner. Put a matchstick near the open end of the delivery tube or pass it through lime water. Why we will do this experiment is in order to find out which type of gas is being released. Whenever the colorless gas is being released, we have to find out what type of gas is. So we will carry out the different experiments to find out those gases which are liberated. Yes, we have to take the test tube. My dear students, we are going to carry out the activity here. We have taken the calcium carbonate in this test tube and then we are going to heat it with the help of Bunsen burner. The calcium carbonate will undergo the decomposition reaction along with the liberation of gas here. We don't know which gas is being liberated, so we will collect it in the delivery tube for testing. And it is observed that when the burning matchstick is brought near this delivery tube where the gas is being collected, the gas will put off the burning matchstick. Then we will come to conclusion that the gas being released is carbon dioxide gas because we know that carbon dioxide gas will put off the burning fire. Yes. And also we will observe that once the reaction takes place, the precipitate is formed here, which is white in color. So what are the observation that we make here? A gas evolves from the test tube and passes all along the delivery tube. The gas puts off the burning matchstick. A white precipitate is formed. These are the observation that we make here. From these observation, we will come to the conclusion. Like calcium carbonate undergo decomposition reaction and it is thermal decomposition because heat energy is being absorbed while the decomposition reaction takes place. So it is called as thermal decomposition reaction. As the heat energy is absorbed during the reaction, it is called thermal decomposition. When the decomposition reaction proceeds by the absorbing heat, it is called as thermal decomposition. Then the gas coming out of the boiling tube will put off the burning matchstick. Then we come to the conclusion that the gas liberated is carbon dioxide and this gas evolved forms white precipitate with lime water. This is one more test for carbon dioxide gas. When carbon dioxide gas is passed through lime water, it will turn lime water milky. CO2 gas turns lime water milky. This is how we will conclude that the gas liberated is carbon dioxide. Now we are going to write the reaction for this activity. We had taken calcium carbonate, which is solid. And when it is heated, it will form calcium oxide plus carbon dioxide, which we have concluded. This is called thermal decomposition reaction. You have to write the name of the reactants and products to make it more informative. This is calcium carbonate. This is calcium oxide. As we know, this is carbon dioxide gas, which is liberated. Note, test for carbon dioxide gas. As we have already studied that when carbon dioxide gas is passed through lime water, it turns lime water milky. See the reaction here. This is calcium hydroxide, which is also called as lime water. The solution of calcium hydroxide in water is called as lime water. This is lime water. When the carbon dioxide gas is passed through this lime water, calcium carbonate is formed, which is not completely soluble in water. This is calcium carbonate. Because of the formation of this calcium carbonate, the lime water will turn milky. This is about the test for carbon dioxide gas. Now we have learned that when the decomposition reaction is carried out by heating, it is called thermal decomposition reaction. One more example also you can give. When lead nitrate is heated, there is a formation of lead oxide plus nitrogen dioxide plus oxygen. This is one more example for thermal decomposition reaction. You should balance the chemical equation here. And it is also possible that the decomposition reaction can also be takes place by passing the electric current. Then we call such decomposition reaction as electrolytic decomposition reaction. Let me give the example for that. Electrolysis of water. Electric current. We will study this reaction with the help of activities in this session on. Yes? And when the decomposition reaction is carried out in the presence of sunlight, then we call such decomposition reaction as photolytic decomposition reaction. For example, when silver bromide is exposed to sunlight, we get silver plus bromine. These are different types of decomposition reaction based on which kind of energy is being absorbed. Let us see one more example for thermal decomposition reaction, that is thermal decomposition of ferrous sulfate. The chemical formula for ferrous sulfate is FeSO4. See the activity here. Take about 2 gram crystals of ferrous sulfate in a boiling test tube and note the color of the crystals and heat. Hold the boiling tube with a pair of tongs and heat it over a flame. In this test tube, we are going to take the ferrous sulfate crystals, which are green in color. Once we start heating these crystals, we are going to make the observations. The observation that we make here are, the crystals are green in color, they changes to brown once it undergo the reaction. And also, the colorless gas with the smell of burning sulfur is evolved. This is the conclusion that we draw from this experiment. The ferrous sulfate crystal will undergo the thermal decomposition reaction. The new substances formed are ferric oxide, sulfur dioxide and sulfur trioxide. Let us write the chemical equation for the reaction. Initially, the ferrous sulfate crystals are green in color. It is actually the hydrated ferrous sulfate which is green in color. Once we start heating this, it will lose the water of crystallization to form white color ferrous sulfate, FeSO4. The hydrated ferrous sulfate is light green in color. Once it loses water of crystallization, it will turn white in color. Again, once you go on heating these ferrous sulfate crystals, what happens? It undergo thermal decomposition reaction to form ferric oxide. This is ferrous sulfate which undergoes thermal decomposition to form ferric oxide, sulfur dioxide plus sulfur trioxide. Ferrous sulfate is solid in state. Ferric oxide is also solid in state, and these two, sulfur dioxide and sulfur trioxide, are gases. This white ferrous sulfate is converted into brown color ferric oxide once it undergo the thermal decomposition reaction. These two are colorless gases which are going to evolve with the smell of burning sulfur. So these are the products formed when ferrous sulfate crystals undergo thermal decomposition reaction. And don't forget to balance the chemical equation. Let's see one more example here, that is thermal decomposition of lead nitrate. Lead nitrate has the chemical formula PbNO3 twice. We will take lead nitrate in a boiling test tube, then heat the boiling tube containing lead nitrate using Bunsen burner. In this test tube, we are going to take the lead nitrate. We are going to heat it with the help of Bunsen burner. What are the observations that we make here? Gas evolves from the boiling tube once it undergo decomposition. The color of the gas is brown. A white residue is formed at the bottom of the boiling tube. From this observation, we are going to make the conclusion. That is, lead nitrate undergoes decomposition. It is thermal decomposition and endothermic reaction. The lead oxide is formed as the lead nitrate undergo decomposition, and the brown color gas is due to the formation of nitrogen dioxide. Let us write the equation for this reaction. Lead nitrate PbNO3 twice. It undergoes thermal decomposition reaction to form lead oxide. This is solid in state. This is also solid in state. Again, there is a formation of nitrogen dioxide gas, which is brown in color, along with the formation of oxygen gas here. This is the thermal decomposition of lead nitrate. You have to mention the reactants and products names. This is lead nitrate. This is lead oxide. This is brown in color. That is nitrogen dioxide. And don't forget to balance the chemical equation. These are different examples for thermal decomposition reaction, and whatever reactions that we have seen here are mentioned in your syllabus. So it is very important to go through all these reactions. Now we are going to see another type of decomposition reaction, that is electrolytic decomposition. The decomposition reaction which takes place in the presence of electric current. Particularly, we are going to see here electrolytic decomposition of water. As we know, the decomposition reaction requires energy in the form of either heat, light, or electric current. In this particular electrolytic decomposition, we are supplying energy in the form of electric current. So, see the activity here. Take a plastic mug, drill 2 holes at its base and fit rubber stoppers in these holes. This is the plastic mug which we have taken here. Drill 2 holes at its base to fit rubber stoppers in these holes, because we are going to fit the carbon electrodes in it to make electrical connection. Insert 2 carbon electrodes into these holes of mug using 2 rubber stoppers and connect the 2 electrodes to a 6-volt battery. These 2 electrodes are connected to the terminals of battery. This electrode is connected to the positive terminal of the battery, and this electrode is connected to the negative terminal, so that this circuit is complete and the electric current will flow through this water. Now immerse the electrodes in water by filling the mug with the water with few drops of dilute sulfuric acid. Why we are going to add here sulfuric acid? Because pure water is not conductor of electricity. So in order to help in the ionization, this dilute sulfuric acid is added, which helps in the ionization of water. Next, invert two water-filled test tubes over the electrodes and switch on the circuit. Now carefully remove the test tubes completely filled with gases. Then bring a burning candle near the mouth of both the tubes to test the gases. What are the observations that we are going to make here? When electric current is passed through this circuit, the water will undergo the electrolytic decomposition reaction. Then we see the gas bubbles appear in both the test tubes. To test which gases are released at these test tubes, what we do is we will carefully remove this test tube which is completely filled with the gases, and we will bring the burning candle near these test tubes. What happens is the candle continues to burn in the presence of the gas from the first test tube. For this test tube, when we remove this test tube and bring the burning candle near this test tube, what happens? The gas will continue to the candle will continue to burn in the presence of this gas, which shows the gas released at this test tube is oxygen. As we know, oxygen is a combustion supporter, which we have learnt in class 8. Then the gas coming from the second test tube burns with a pop sound. When we remove this test tube which is filled with the gas and bring the burning candle near this test tube, what happens? The gas will burn with the pop sound, which shows the gas which is liberated at this cathode is hydrogen. Because hydrogen gas will burn with the pop sound, which shows the gas which is liberated at this cathode is hydrogen. So from this we conclude that oxygen gas is evolved at anode and hydrogen gas is evolved at cathode. And also we will observe that the volume of gases collected at these test tubes are not same. Volume of the hydrogen gas collected is double the amount of volume of oxygen collected. Actually, what is the reaction that takes place here? Let's see. The water will undergo electrolytic decomposition to form hydrogen, which is gas, and oxygen, which is also gas. Balance the equation. There are two oxygens here, so I will write 2. Then 2 2s are 4 hydrogen atoms here, so I will write here. You can see here the amount of hydrogen is double the amount of oxygen produced. As we see in this formula, the number of hydrogen atoms is double the number of oxygen atoms. There are 2 hydrogen atoms per molecule of water and only 1 oxygen atom per molecule of water. So the amount of hydrogen gas collected is double the amount of oxygen collected. The volume of hydrogen is twice the volume of oxygen collected. You have to remember this. So overall, this is the reaction of electrolysis of water, where the water will undergo electrolytic decomposition to form hydrogen and oxygen on passing the electricity. Now let's see the photolytic decomposition reaction. Here, the decomposition reaction takes place in the presence of sunlight. Let's see the example here, that is photolytic decomposition of silver chloride with the help of activity. We will take silver chloride in a watch glass. Observe the color of the silver chloride before and after the reaction. Place the watch glass under the sunlight for some time. We have taken the silver chloride in the watch glass. Silver chloride is actually white in color. Once it is exposed to sunlight, it will undergo the decomposition reaction. Then what is the observation that we see here? The color of silver chloride changes from white to gray. This shows it has undergone the decomposition reaction in the presence of sunlight. We conclude that in this reaction, the compound silver chloride decomposes under sunlight. This is why it is called photochemical decomposition and is endothermic reaction as the energy is absorbed. Next, the gray color product formed is silver. Now let us write the equation for this reaction. Silver chloride AgCl, which is solid in state, it will undergo photolytic decomposition. You have to mention which type of energy is absorbed. Form silver and chlorine. The chlorine is liberated in the form of gas here. This is silver chloride. You have to mention the reactants and products. Silver chloride. This is silver. This is chlorine. Balance the equation. Then the chlorine is liberated in the form of gas. And also silver bromide also behaves in the same way. When silver bromide is exposed to sunlight, it will form silver and bromine. These two reactions are used in black and white photography. This is the application of these two reactions. It's all about the different types of decomposition reaction.